Alright, ladies and gentlemen, we are trying to solve this equation. Log base 2 of s plus 32 minus the log base 2 of s plus 5 equals the log base 2 of s. Now, the best way to approach this equation, and it's a little bit different than our others, the left-hand side of the equation is calling for the quotient law. When you have the log base 2 of a quantity minus the log base 2 of a quantity, the minus indicates that's the quotient law. You write the single log base 2 of the quotient. So that's our first step in this problem, is the left-hand side compresses to the log base 2 of one argument. And here we have the log base 2 of another argument. Now when I say argument, I've used this phrase before. This is called the argument of a log function. It's what you're putting into it. So the argument here is s plus 32 over s plus 5. The argument here is s. Now, I have the log base 2 of some argument equals the log base 2 of another argument. Okay? Now normally we don't have a log over here. Normally this is just a number, and we convert this into exponential form. But that's not what's going on here, okay? What we have over here is a log function. Here's a log function. I personally think the best way to approach this is to make this recognition. If the log base 2 of one quantity equals the log base 2 of another quantity, then what we do is we set the two quantities equal to each other. In other words, set the arguments equal to each other, and we ignore the log function. Now, very important you understand why, okay? But this is the step that I do. If the log base 2 of a number equals the log base 2 of a number, then the two quantities, the two arguments are equal, and we'll proceed from here. But here's the reason, okay? I hear some students say bad things, like sometimes they'll say, well, what did you do? Just divide out by the log of 2? No, people, the log of 2 isn't something you can divide by. I mean, log is a function, for goodness sakes. No, you didn't divide by it. But here's what happened. The log function is a one-to-one function. So basically, here's what that means. If their answers are equal, if the two y values are equal, then the inputs must be equal as well. And that's because log base 2 is one-to-one. Okay? So, if the answers are equal, the arguments are equal. Now we proceed from here. I multiply, or actually I could just cross multiply. So I have s plus 32 equals, and then we cross multiply here and get s squared plus 5s. Okay, this is a quadratic equation. I'm going to set one side equal to 0 net. So I'm going to do minus s minus 32. Alright, and that's going to bring me down to 0 equals s squared plus 4s minus 32. Luckily, this expression factors as s plus 8 times s minus 4. So we get two possible solutions. This solution from this factor would be a negative 8. The solution by setting this factor equal to 0 would be a positive 4. Okay? Now, what we have to do, because this was a log equation, is check our answer. Let's try negative 8. Let's go back to the original problem. Okay? Well, I don't have to look too far. If I try to put a negative 8 in here, I'm taking the log of a negative number. Forget it. Nope. Let's try 4. 4 plus 32 is a positive, so log of a positive is good. 4 plus 5 is 9. Log of a positive, that's good. 4 is positive. Log of a positive, that's good. So my solution set here is 4. The set containing 4. Always remember when you're solving a log equation to check. Okay? Now, one of the things I want to caution you about, it's not always the negative answer that fails. Sometimes the positive fails and the negative works. What you have to do to decide is go back and check. And when you plug in whatever you think your answer is, this number needs to remain, this quantity needs to remain greater than 0, the same here, and the same here. Okay? So we are done.